Okay, there are some shortcuts that we can take when we have more than one resistor and we're trying to find out something about what's going on one of the resistors. So let's talk about what we can do if we have resistors in series. So here I have two resistors in series, and if I know the voltage at one end, I'll call that VA, and the voltage at the other end, I'll call that VB, then I can say that the total voltage change across that is VA minus VB. So that would be the voltage at one side minus the voltage at the other. So an example of this would be if I had a voltage source here, and I had two resistors, and it goes around in a complete circuit, then the total voltage is just going to be VT. It's just going to be that voltage source, because I could call this ground, and then this would be VT, and so our total voltage there would just be that voltage source. So if I have two resistors in series, so voltage division you use for resistors in series, and you need to know the voltage change across all of the resistors. And so if you know the voltage change across all of the resistors, then you can use voltage division, and this will find, if I call this, if this is resistor 1 and resistor 2, and I want to find out V1 or V2, so I want to find out the voltage across one of those resistors, then I would use voltage division, and what it would give me is that V1, so the voltage across R1, equals the voltage change across both resistors, so that's VT, times R1, that resistance, over the total resistance, which is R1 plus R2. Now, it doesn't have to be that it's just two resistors. I could have more resistors, so let me show you how that would work. So if I had, let's say I had this, so I have VA and VB, and then so VA minus VB is V total, and this is R1, R2, R3, R4. If I want to find the voltage across, say, R3, then V3 is going to equal V total times R3 over R1 plus R2 plus R3 plus R4. So it's the single resistor over the sum of all of the resistors. And the reason this works just comes from Ohm's law. When you have resistors in series, when you have anything in series, so resistors or anything in series have the same current, but not necessarily the same voltage. They would have the same voltage if they were identical. Like if I had let's say I had a 12 volt voltage source, and I had two identical resistors. It actually doesn't matter what they are, but let's say that's 4 ohms and 4 ohms. I know the voltage drop across each one of them is going to be 6 volts, because it has to be even. So use voltage division when you have resistors in series. What if you have resistors in parallel? So if you have resistors in parallel, then you can use current division, because things in parallel, anything in parallel, has the same voltage but different currents. or they might have different currents. Again, if they're identical, they would have the same current. So let's look at an example. Let's say I had a 4-volt voltage source, and I had 2 resistors. Let's say that my resistors are both 2 ohms. Well, then I can be pretty sure that whatever my current is, it's going to divide itself up equally and go through both of them. Actually, I'm going to change this to a current source just so that I'd have one less step to do. So I'm going to make this a 10 amp current source. That's a large current source, but a 10 amp current source. So if these are identical, then I have 5 amps on each one. So it makes sense that it would divide up equally. But they don't have to be equal to find out what the current is. So here's how current division works. You have your total current, and let's say I'm just going to put 2 of them in here because adding resistors in parallel is not as easy as adding them in series. So let's say I have my total current IT, and I want to find I1 and I2. So I1 is going to equal my total current times, and this is the opposite from voltage division, times the other resistor, so times R2 over R1 plus R2. So in this example right here, if I change this to be 4 ohms, well, first of all, we would expect that we would have twice as much current going through the 2 ohm resistor than through the 4 ohm resistor, because the 4 ohm resistor has 4 times the resistance. But let's see if that's what actually happens. So the current, if this is I1 and this is I2, I1 will equal my total current, 10 amps, times the other resistor, 4, over the sum of the resistances, 6, or 10 times 2/3, or 20/3, and then whatever that is. And then similarly, I1 equals I total times R2 over the sum of them, and I2 would equal I total times R1 over the sum of them. Now, what do you do if you have more than 2? Well, you have to be careful. It's not as easy as with voltage division, because you can't just add resistors that are in parallel. You can't just add the resistances together. So what you would have to do in this case, let's say I wanted to find I1, what I would have to do would be to first replace R2 and R3 with their equivalent resistor. So that would be so I would replace it with the equivalent resistance. So I'd have I total, and then I would have R1. I don't want to change it. And then this one would be REQ, and REQ is going to equal R2 times R3 over R2 plus R3. And then whatever number that is, then that's what you use in your current division. And so you have to actually find this number and use that, so whatever that is. So that is voltage division and current division, and that's it for now.